Hello everyone, welcome to Collegewali PADHAI. So in today's chemistry episode, we are going to discuss how to identify whether a compound is aromatic or anti-aromatic or non-aromatic. So let's get started. So let's start with the instructions that how to get to know that whether a compound is aromatic or non-aromatic or anti-aromatic. So first let me start with the instructions part. Instructions. So, how to know whether a compound is aromatic or anti-aromatic? So, if both of these condition fails, then it will go to non-aromatic. So, the compound must be cyclic, the compound must be planar, the compound must be conjugated. So these are the basic instructions for aromatic and non-aromatic. It must be cyclic, it must be planar, it must be conjugated. And how to know more appropriately about identifying whether the compound is aromatic or anti-aromatic without any thinking part, directly you can say that whether it is aromatic or non-aromatic. So let's move to that part of the video. So if you want to know that a compound is aromatic, sorry, let me tell you about pi bond. So a single pi bond has two electrons. Single pi bond has two electrons. Then for aromatic, how to know whether it's aromatic or not? For aromatic, it must have 2, 6, 10, 14, 18 electrons. If any of these number of electrons are present, then it is aromatic. And for no anti-aromatic, it must be 0, 4, 8, 12, 16, 20. If these number of electrons are present, then it will be anti-aromatic. For non-aromatic, if both aromatic as well as anti-aromatic condition fails, then this will lead to non-aromatic. Understood? So you must take a screenshot of this to be much more clear. Pi bond, 2 electrons. If 2, 6, 10, 14, 18 electrons are present, then it's aromatic. If 0, 4, 8, 12, 16, 20 electrons are present, then it is anti-aromatic. And if both aromatic as well as anti-aromatic condition fails, then this will lead to non-aromatic. So let's get started with the examples. Okay, so now let me erase the full part. Oh, yeah, here we can do. So let's get started with the first example. That is this one. Pi bond, then extension of hydrogen and a positive sign. So can anyone tell in the comment section that how many electrons are present here? You can see this pi bond over here, only a single pi bond, which means how much? 2 electrons. when two electrons are present, then it is aromatic. Simple. You can see a single pi bond. Single pi bond means two electrons. So if two electrons are present, then it is aromatic. Then let's move to the second example. This one. Here one the plus sign, hydrogen, hydrogen, and here single pi bond. Here also single pi bond is present, which means two electrons. Two electrons, which means it is aromatic. Understood? And you can also check side by side whether they are cyclic or planar or conjugated. You can check this side by side. Let's move to the third question. Okay, how to... Yeah, we will erase this or what? How to erase? Okay, insert, undo, redo. Okay. Okay, let me erase this and do. Yeah. Yeah. So here we will do question number 3. Question number 3 is similar to the first one, but with little changes. Yeah. Extension of hydrogen, then here lone pair along with the negative sign, then here a pi bond. So here, can anyone tell whether it's aromatic or anti-aromatic? So as there is a single pi bond present over here, single pi bond means two electrons. Single pi bond means two electrons. So you must have thought that it's aromatic, but actually it's not aromatic. Here you can see a single pi bond is present, which means two electrons. You must have also noticed a negative sign over here. Negative sign also means two electrons. So 2 electrons plus 2 electrons makes 4 electrons. So it is anti-aromatic. So it is anti-aromatic. But if a negative sign is present, you must consider that as 2 electrons. But if a positive sign is present, no need to consider this one. This is the main thing which must be kept in mind. Sorry. So let's move to the fourth question. Let me erase this one. Yeah. Yeah, erase. Yeah. So fourth question is excuse me, square 2 pi bond. This is a simple one which everyone can answer. 1 pi bond, which means 2 electrons, 4 electrons. So simply it's anti-aromatic. Done. This you must have understood easily. Then let's move to the fifth question. Fifth question is just like this. Then here, then here, then extension of hydrogen with a positive sign, pi bond. So here also you must have easily seen 2 electron, 2 electron, because here a pi bond is present, here a pi bond is present, 4 electron. 4 electron means of course it is anti-aromatic. Done. Then let's erase this and move to question number 6. You can pause or reverse the video and take a screenshot or note down in your copy or somewhat of your choice. So now let's move to question number 6. Question number 6 is something like this. There, here, then, well, why my pen is not working? Yeah, something like this. Then here H hydrogen is extended over here with a lone pair, two lone pairs and a negative sign. And here one pi bond and here one pi bond. So here how many electrons you can see? Here a pi bond is there, here a pi bond is there, and here a negative sign is also there. This means 2 electrons. This means 2 electrons. Negative sign also means 2 electrons. So 2 plus 2 plus 2 is 6. 6 electrons are present. When 6 electrons are present, it is, yes, aromatic. It is aromatic. Done. So now let's move to the seventh question. Seventh question is what? Yeah. This. Let me erase this one. Yeah. Sixth erased. Yeah. Let's move to question number 7. So question number 7 is little different, but actually I will show you three diagrams of the same answer, but you need to recognize that part. Let me also erase this, you must have known. Yeah, question number 7. Three diagrams I will show you. This is one. O, lone pair, lone pair. This is lone pair. Another is N, lone pair, bond, bond. Here hydrogen extended, R1, 2, here S, and here here one bond. Here one, it is also one pi bond. Don't miss it. Okay. So here these three have same answers. Don't, if you means guess this and don't say that this is also same or this is also same. So forget it. So let's get started. One pi bond, another pi bond, lone pair. Wow, two electrons, two electrons, two electrons, 6 electrons. Here also 1, 2, 3, 4, 5, 6. Two pi bond and another lone pair. Here also 6 electrons. Sorry. Here also 1, 2, 3, 4, 5, 6. 6 electrons. So when you have 6 electrons present, so this will be aromatic. So I will explain this part by erasing this. You can take a screenshot Yeah, let me explain with the help of a single diagram. Okay, let me erase this. Yeah. Hmm. So let me explain with the help of this single diagram. Oxygen, lone pair, pi bond, pi bond. So this you already know that this is a pi bond, which is 2 electrons. This is a pi bond, which has 2 electrons. This you are clear about till now. But you have to also consider the lone pair as 2 electrons which are present inside the compound. Which are present inside the compound. But if something like this is present here, means if some lone pair is present outside the compound, then no need to consider this. Only consider the regular pi bonds, this one, and the lone pair which is present inside. No need to consider this lone pair which is present outside. So this will give 2, 2, 2, 6 electrons, which is obviously aromatic. So let's move to the next part of the question. So now this question you have to guess whether it's aromatic, anti-aromatic or non-aromatic. This will be question number 8. Yeah, so yeah, this will be question number 8. So the what happened? Yeah, diagram is something like this. Yeah. Here one, here one, and straight line over here. Yeah. So I have made the diagram little tedha tada, but it's almost accurate. One pi bond over here, one pi bond over here, another pi bond over here, another pi bond over here. I think it's confusing. I have to draw it once more. Sorry. So let me draw this part. I will draw the pi bond in red color pen or blue color. I will draw it in blue color. So here there is a pi bond, here there is a pi bond, here there is a pi bond, here there is a pi bond. So how many pi bonds are present? 1, 2, 3, and 4. This one. So 4 pi bonds are present, which means 2 electrons over here, 2 electrons over here, 2 over here, 2 over here. 2, 2, 4, 5, 6, 7, 8. So total 8 electrons are present. So it will be anti-aromatic. So it will be anti-aromatic. Wrong. Answer is wrong. It is not anti-aromatic. You need to see. Let me undo this total part. Yeah. You need to see the structure. Can you see this structure as cyclic? No. Can you see this structure is planar? No. Can you see is this structure conjugated one? No. So as it is not satisfying the conditions of aromatic as well as anti-aromatic, so what it will be? I know it has 1, 2, 3, 4, 5, 6, 7, 8. 8 electrons. You can say that it has 8 electrons. But as it is not cyclic, not planar, not conjugated, so it is not satisfying aromatic as well as anti-aromatic. So this is non-aromatic. This is non-aromatic. Understood? I'm giving you some few seconds to see. I mean, take a screenshot. Taken. Okay. So now let me erase this total part. Now we will move to question number 9. Exciting concept. Yeah. Now we are heading towards question number 9. So this diagram will be something like this. 1, then 2, 3, 4, then 5, 6. I will draw all the pi bonds in blue color. So here there is one pi bond, here there is one pi bond, here one, here one. Can someone say I'm giving you 5 seconds whether it's aromatic or anti-aromatic or non-aromatic? You can pause the video and answer in the comments. Yeah. Here pi bond means 2 electrons. Here another pi bond, 2 electrons. Here another pi bond, 2 electrons. Here another pi bond, 2 electrons. 2 plus 2 plus 2 plus 2. 4. Sorry. 8. 8 electrons is what? Anti-aromatic? No. But it's not anti-aromatic. Have you seen these two over here? So whenever you see any kind of charges, you have to consider that also. Inside 2 plus 2 plus 2 plus 2, 8 electrons are present, and outside 2 minus is their charge, and you have to also add that charge as plus 2 electron. So now it will give 10 electrons. 10 electrons means it is aromatic. Simple. Take a screenshot, then we will move to our next question. Yeah, done. Okay, let me erase this part. Yeah. So now we will move to question number 10. Yeah. So question number 10, this one is a conjugated one. First like this. Here one. Oh, sorry. To erase this one. Blue color to do all the 5 one. Here 1, 2, 3, 1, 2. So this is the compound. Pi bond, pi bond, pi bond, pi bond, pi bond. 2, 4, 6. 6 electron. 4 electron. Total 10 electrons. 10 electrons means it is aromatic. Simple. This one is a simple one. Then we will do the last question, which is similar to this only. You first take a screenshot of this. Taken. So let me erase over here and do this here only. I will redo it. Undo or redo. Undo, undo. So I will erase this part. So now we are doing question number 11. Excuse me. I have to erase this part also. Slowly. Yeah. Join this one to do another one also. Yeah. Now I have to show all the 5 bond here. It's okay. Here also I have to do like this. 1, 2, and 3. This one is also simple. You can see 2, 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14. Total 14 electrons are present as each pi bond consists of 2 electrons. 14 electrons are present, so obviously it's aromatic. As simple as that. So this was the video about whether compound is aromatic or anti-aromatic or non-aromatic. So at the end of this video, I would give a sweet gesture that is none other than a thank you. Thank you for watching the video till the end. Do subscribe to the channel, like the video, and share with your friends to learn more. Thank you.